Bismillah, Assalamualaikum warahmatullahi wabarakatuh. Today we will be focusing on free body diagram. This is what we have learned from early on in the semester, but given that most of the chapter that we cover in this subject, when we want to solve equilibrium problem, we have to draw free body diagram, right? And even up till the end of the semester in the quizzes, I still notice some basic mistakes, or something that should not have happened with regard to free body diagram. So here we are to revise the basic concept of drawing free body diagram. Now, to put in context, in terms of the examination, and tally with the philosophy that as an engineer you should not only know how to compute something for your own self, but also to present your analysis, your calculation for others, and they should be able to understand it, right? So when you draw free body diagram in this course, in terms of the examination, the marks is given in accordance to that philosophy, right? Meaning that if only you can understand what you draw, then you will not get any marks for that, right? So others should be able to understand it as well and make sense of what's going on in the free body diagram, right? So with that, when we draw a free body diagram, so there's two items that I'm going to be focusing. Now, number one is with regard to the body itself, right? So when we say free body diagram, it should be clear just looking at it what or which body are you referring to, meaning what exactly that you consider as the body of the free body diagram, right? That's number one. And number two is all the forces that should be in that free body diagram, right? All right. And basically there's two types of free body diagrams that we have learned. One is equilibrium of a particle, right, as well as a rigid body, right? A particle or rigid body. For this kind of free body diagram, we have used in terms of, for example, if we have a case of, for example, we have a ring there, and then we have a cable somewhere, and then we have a load, for example, right? Case like this. Or in the case of, in chapter 6, we have learned about trusses, right? So for example, we have trusses. Let's say something like that. Let's say, right? And to draw the free body diagram, first is about the body, right? Meaning that if in this case we are focusing on this particular thing, right? Okay, is this clear? The red, I hope you can see that, right? We focus on that ring, and when you draw the free body diagram, the body is simply that. It's a particle, right? And then you draw the forces. So in this case you have the three forces, right? And in this case, let's say you are focusing on this point over here, let's say, right? This point, the pin that is connected to this 1, 2, 3, 4 members. So basically you have the body itself is just a particle, and then all the forces, meaning you have forces from here, from here, from here, and from here, right? So that is when we talk about body. For equilibrium of a particle, it's simply just, it simply is just the particle itself. And for rigid body, this is when we have then chapter 5 onwards. It can be, for example, if you have a beam where you have, say, this is simple one, a pin here and a roller here, for example, right? And then a force somewhere here. So the body is when we consider, okay, the body that I'm considering is the beam itself. So how you draw, you have to remember that we draw, okay, let me use this one, the outline, right? The outline of the body, meaning that if this is the member, this is the beam, so this is the body. Do not just draw one line. Why? Because for yourself, you may understand what's going on, but for others, it is different. It is difficult to differentiate which is the body. And you might say, well, you just refer to this and you know which is the body, but the free body diagram should be able to stand on its own and it is understood. Okay, this is the body, this is the axis, this is the forces, right? If you draw the body itself as a line, then is it an axis, is it a length, the dimension, or is it what, right? The force, so it's not clear. And then you have all the forces. Let's see, it becomes something like that, right? Of course, when we deal with rigid body, then all the understanding of support actions comes to mind. I'm not elaborating on that in this video. I'm just revising what you need to do, because just drawing the outline of the body itself, many did not do that, right? So I'm highlighting here, if you do not want to miss out totally the marks of free body diagram, please draw the outline of the body, right? It can be a member like that. What else? It can be, I don't know, maybe if you have a box here where someone is pushed there, and this is, for example, from friction, right? And then you have friction there. So the body itself is just this box, right? You cannot still have the surrounding, because when you say free body diagram, it should be already free from all the surrounding. So the ground, the person, the roller or whatever should not be there. And then you have all the forces. The forces, maybe the weight, the normal reaction, the friction, for example, in this case. Right. Now, next is about the forces. About the forces, there are two things here, right? So it can have a known value, and also can have the unknown. And normally the unknown is what you have to solve, right? So in any particular free body diagram, anything that is known should be written with the value, right? Known meaning that the value is known. For example, if the weight here is known to be 10 Newton, then you have to write 10 Newton. For example, this one is not known, so you have to label it. For example, F, A, F, B. Right, for example. Here similarly, right? So we name it according to the member. And anything that is known already, the value should be there. Right? So if anything that should be known, but you do not write the value, you miss out on the marks as well, because that should already be in the free body diagram, because it's a known value, it's a known force. Similarly in this case, right? So the same goes. Of course, I'm only showing 2D, because in 3D the same principle applies. It's just that, of course, you have to deal with 3D support actions, etc. Of course, in terms of all of this, I will not elaborate in detail here, because we deal with it in respective chapters, right? Make sure when you deal with friction, you know exactly what is the direction, because the direction is not assumption. When you deal with friction, the direction should already be known, meaning it's not, I'm not assuming it's to the left or to the right. I know it will be to the left in this case, right? So that is, go back to chapter 8 if you do not understand that. And also make sure when we deal with, because when we deal with chapter 7, which is internal loading, internal forces, you have to draw the free body diagram as well. Make sure you understand that as well. But what I'm emphasizing here is to draw the outline. For example, right, in friction, if you have a ladder like this, right? So when you draw the free body diagram, the body itself is just the ladder, right? Now, there are some students, even until the end of the semester, still draw something like this. They draw this, they do this, they do this, and then they draw the forces, and the forces, and whatever, right? But if you just show this to someone else, is it clear what's going on here? Is it clear what is the body? Where is the body? Right? Of course, you may be clear, right? And from here, you can calculate on your own because you understand what's going on. But if you just show this drawing, it's not clear. Is it something like a triangle? Right? So that's where, in terms of the marking of the free body diagram, it is going to mark in that way, right? Meaning that just show the free body diagram, it is clear on its own, right? For example, in this case, then if it have its own weight, then its own weight, the normal reaction, friction is if there's a friction if there's a friction, something like that. And again, all the known force, all the unknown force. Yep. Additional point. Where, because when we draw something, it should also represent what it is, right? For example, in this case, right? What if I draw it like this, right? Instead of on top, you draw it somehow. When you draw the free body diagram, you draw it like that. Now, in terms of calculation, it is not affected, right? When you calculate summation of Fy, when you calculate summation of moment, you still get the correct answer. But just looking at it, the perception is different. Because I would assume, for example, it is something like if you have a weight here, right? And then you draw it like that, right? Because something is pulling from down. But if you have something pushing from up, from on top, you would draw it like this, right? So that is where I think when you draw something, make sure it is, meaning the representation is making sense, right? For example, roller here, right? The effect on the body is it's supporting from below, right? The roller prevent it from going down. If you draw the force here, I would understand it as something that is pulling from up, right? For example, if you have a cable like that, right? So it is okay, this force is pulling it up, but this one is actually pushing it from below, right? So make sure it makes sense as such, right? So for example, this normal reaction, we draw it here, we do not draw it upwards there, right? So I notice many students that, for example, like this, right? Why we draw it here and not here, for example? Because some students say, no, sir, it's just the same. The direction is like that. When we calculate, it's like that. But no, it gives you a totally different idea of what's going on, right? So this one, it represents that member, right? So of course, in trusses, this one will because when we deal with tension and compression, everything will be off if you draw it wrongly like that. Anyway, so that's for free body diagram. Hopefully that is some refreshment of what you need to already have understood. And in terms of application in your final exam, hopefully it helps to avoid you missing out on the marks from the free body diagram. Alright, so of course there are others that leads to any of this. For example, we have distributed loading. I'm not giving an example, but you know what to do, right? You should know already what to do when you have distributed loading. Find the equivalent force, etc., right? And then you draw the appropriate free body diagram. Alright, I think that's all for this refresh on free body diagram. Hopefully it helps, especially in terms of avoiding losing marks in the final exam. Wallahu alam, wassalamu alaikum warahmatullahi wabarakatuh.